Flue Gas Capture Technologies, Pre-combustion, Post-combustion, Oxy-combustion by Jay Geist and Peter Ololo. First you see we have the pre-combustion setup here. This one has an air separation unit which will take in air from the atmosphere and separate it into oxygen and other gases, mainly nitrogen. The oxygen then mixes with fuel, here in the gasifier. The gasifier then creates a syngas. This syngas goes over to the shift reactor where it is mixed with steam. This creates hydrogen and carbon dioxide. The carbon dioxide then gets sent to the compressor, which is then used for capturing and storage. One of the pros about this is that there is low technical risk and it is most likely to become the most efficient in the future. One of the cons is the amine regeneration isn't cost effective yet. Here you see we have a post-combustion setup. As you can see, these first three things are very standard on all operations, with your boiler, the fly ash separator, and the sulfur or SO2 scrubber. What we're focused on here is the CO2 absorber and the amine regenerator. These go in after the line. And what happens is, after the flue gas is scrubbed for SO2, it goes into the CO2 absorber, which the CO2 gets captured by the amine. It is then scrubbed, regenerated, sent out to compression, and then flue gas goes on out. With this, it is easily retrofitted to most power plants, but it has high initial investment cost, especially for the amines. Here we have an oxy-combustion setup. Like before, it deals with an air separation unit, which separates out oxygen from the rest of the atmospheric air. The oxygen then goes into the oxy boiler, where it is mixed with pulverized coal. It is burnt, creating steam and fly ash. The fly ash then gets separated and goes into the sulfur scrubber, and then the flue gas is sent through a condenser, creating a liquid flue gas. This then goes to the gas processing unit under high pressure, where gravity separates the CO2 from the nitrogen. As you can see here, one of the big things is that you have to have return lines to help power the plant. One of the benefits, though, is that there's high CO2 flue gas concentration, but there's large energy requirements for the process. From these three steps, you can see that the CO2 can go to potential sequestering sites like you see here in Utah. For more information, please see these sites and use the keyword carbon sequestration.